Hey everybody, welcome to the last session of today for 420. This is Supercharging Game Development with Microsoft, Cloud Native, and AI Technology. My name is Max Felker, and I'm an Enterprise Architect at the Microsoft Partner and Customer Solutions, or MCAPS division. So today, we're going to do a little bit of introduction, and we're going to talk about what is Cloud Native, and then what makes a game Cloud Native, and then how GitHub Copilot shortens the time to write the code. And then we're going to actually build and deploy a game in real time. And that's not going to be anything cooked. It's not a cooking show. We're actually going to see it live. I'm going to crack open the programming, and we're going to do it live. So there will be bugs. There might be problems, but we're going to do it, and it's going to be fun. That's part of build. So my name is Max Felker, and I've been building games for as long as I can remember. I grew up on tabletop RPGs, the 56K modem, and DOS. I'm an indie game developer myself, and I'm working on a game that I've been building and thinking about for as long as I can remember. I built my career at Microsoft over 15 years, working in the professional engineering space, and now today I work as an enterprise architect where I teach people cloud native and AI technology. And you can see with this upside down picture here that you'll be able to follow me on LinkedIn or GitHub just by looking at that. So what is cloud native? Cloud native engineering is an approach to designing, building, and scaling solutions that takes full advantage of the cloud computing model. To be cloud native means that you and your team are using cloud native tools, implementing cloud first approaches, and using cloud native compute targets to deploy your solutions. When teams adopt cloud native best practices, they will see benefits such as reducing the time that it takes to release solutions and gather user feedback, increasing the solution compliance, live-site resiliency, and team confidence when shipping, and reducing the cost to build, ship, and maintain the solutions. Today, we're going to be talking about some specific tools and technologies from Microsoft and its partners, which include, but are not limited to, Visual Studio Code, Docker, Azure Command Line Interface, Bicep, GitHub, and Azure. Hello World is your first feature. The first activity of any production-first or cloud-native engineering team is to establish the infrastructure, the pipeline, and the cloud environments in which the customers will interact with before moving on to shipping any product requirements. This allows teams to ship the release to the user and then gather feedback. Most of the time, this feature will be a hello world, which will allow users to access the application or the solution without any assistance from the team building it. This, which allows people to get feedback, is something that we tend to think of. We build everything first, and then we deploy it. And instead, it allows us to build and then deploy quickly. It's not about building all of it. It's about building the first part. And the first part is getting a link to your users. You don't have to crank it, show them a desktop, do the over-the-shoulder demo, as we call it, on localhost. It means that it's actually in the cloud working. So each machine is unique, and that's actually the problem. It's common for engineers to use personalized work machines and various hardware, various operating systems, and software configurations of their choice. Remote environments are optimized for the cloud, and typically they differ from our work machines. The unexpected issues arise because the remote environments have a delta between the local environments and even the remote environment siblings. When running the code locally on our bare metal work machines, we recognize that it's not identical to the execution that's in the remote environment. The deltas presented cannot be resolved without a layer of abstraction, and that causes problems down the pipe. So it works on my machine, but doesn't work on your machine. Works on our machines, but doesn't work in production. And the reason is because we see something like this. When teams have 1 or 2 developers, the problem is fine. But beyond that, it gets compounded as the number of work machines are added. So here's how a 3-person team could look running a node project. As we can see, each engineer has a different operating system, as well as various versions of the node platform. And so when compared to other things, such as the app service in UAT and in prod, they're all running different things. Node 16, Node 18, Node 14. That's going to cause headaches, and anybody who's tried to do node package management knows that that is a real problem. So abstracting the deltas away through immutability, here we see the same project with the same developer team using a Docker approach, using containerized images. Container images are immutable composites of software solutions that include the runtime and the environment configurations. Engineers can use common images, regardless of their host machine, to abstract the deltas away and to ensure that the solution runs the same way every time. So continuing the example below, or right here, here's how this team would look at it. We have a node project that runs on a node Alpine image, and Docker helps us deliver the same experience regardless if you're local, you're remote, you're on Mac, Windows, Linux, or maybe even something else. So why is this so important for you and your team? Microsoft has been leading the industry in cloud-native teams, ecosystems, and culture. So below is an excerpt from Microsoft Learn about why cloud native is so important to organizations. I'm going to read it to you because it's super, super important. Cloud native is about speed and agility. It's imperative to get new ideas to market quickly. Business systems have also become increasingly complex with users demanding more. They expect rapid responsiveness, innovative features, and zero downtime. Performance problems, recurring errors, and the ability to move faster is no longer acceptable. Cloud-native systems embrace the rapid change, the large scale, and the resiliency that our customers desire. So in this context of our talk, customers are gamers, and they're directly impacted by our ability to deliver quality solutions in a timely manner. As we approach existing projects or new projects with the same way we've been doing it for the last 20 or 30 years, we're going to see the same exact results, which is multi-quarter delivery timelines, month over month and year over year increased spend, and complexity that goes at the same rate or greater as the size of the solution. So we talk about standardizing the output of engineers by adopting immutable containers as a cornerstone technology. We can see a relatively basic pipeline. Now, not all of this technology is exclusive. You could use other things like Visual Studio, Azure DevOps, and other systems, but this is just the system that we're going to talk about today. So we can see that there's VS Code, commits to GitHub, that triggers a build, it builds a Docker image and goes into a container registry. So regardless of the language, the team, or the project, the output of the container-based engineering team is a container image. All the images are placed in a catalog, which is available to any member of the team. And as the team standardizes around this Docker implementation, we can start to share and utilize common artifacts across teams and across organizations. And so that's actually how the Docker ecosystem and all of the container-based and cloud-native ecosystems work here at Microsoft. We even have our own container registry called Microsoft Container Registry, which has a bunch of our container images. And so some of the images that you're going to see today, we used. Now we're going to switch over to something called GitHub Codespaces. A code space is a development environment that's hosted in the cloud. Instead of setting up your environment each time, you can start building features right away. Codespaces allows engineers to build and deploy quickly, rapidly, and use iterative deployment approaches. At Microsoft, we're in the process of moving away from long-lived, heavy spend, compliance-intense, shared development environments. So no longer are we working on a dev environment that everybody gets access to. We have independent, short-lived development environments. And so we're going to take a look at what Codespaces looks like under the hood. It's VS Code. It's actually just VS Code. It's a remote workspace called a GitHub Codespace. And it works on your desktop. It works in the browser. And you could also use it in Microsoft DevBox, which is a virtualized experience in the cloud for a Windows experience, like running a PC in the cloud. And so it connects remotely, and everything is running in the cloud, but it works like it's local. That's the beauty of it, is that as developers, we don't have to worry about setting up development environments, provisioning our keys, trying to figure out how to get fully qualified domain names for this short-lived development environment that we're only going to need for this feature branch in this sprint. So now, what does it mean to be cloud native for game development? Games are built on CDs. They're deployed in big bundles, huge, tens or hundreds of gigabytes in size for every single person. Why does that matter? Because the people, the teams, the organizations that are hosting those files are paying for it. And as indie game developers, we deploy to the cloud. We deploy to systems that we have to pay for. We don't have an endless budget. And as a result of that, the pull-down cost, the upload cost, increases as the number of users increases and the size and complexity of our game increases. So while we have a small game, that's totally fine. But if you're trying to build something like a AAA title, we're talking hundreds of gigabytes of size. And that's a lot of money. And so what we're talking about now is a cloud-native implementation pattern for games. And it's very similar to what we would see in a cloud-native web application. The only difference is that the game experience isn't just a single monolith, it's broken up into 3 pieces. The game experience, the presentation layer, and the persistence layer. The data persistence layer happens via RESTful API. So rather than storing things locally on the machine, on the disk, we are storing we're storing that data in the API inside of Azure Cosmos, or it could be something else like Postgres or multiple databases. But the RESTful API creates a common way of interacting with the data. As a result of that, we can expose that data to a single-page application. So things like logging in, user accounts, preferences. They don't get stored on the disk, and we don't have to figure out about syncing them across devices because they're already in the cloud, making it cloud native. And so we can also do things like stick builds into storage accounts and do automated builds into storage accounts. So that means that we don't have to worry about how the builds are going to get up to the site. We can automate that away. And the real benefit is actually that the Unity client, in this case, or any game client that can make a RESTful or HTTP, any protocol over hypertext transfer, can be made and interact with that data. And so this implementation allows us to bifurcate, or in this case, trifurcate the game experience, presentation layer, and persistence layer so that we can work on them independently, allowing us to ship features incrementally in the parts that we need to. So this is an overview of the cloud architecture that we're going to see in the demo later, and we're going to talk about a couple of these resources and what they mean. So we have a few different resources here: container apps, container environment, container registry, Cosmos DB, and cloud storage. Each of these make up part of the solution, and you can see the links to them on Microsoft Learn. And there's a lot in there, and each one is very deep. So I'd recommend checking them out and going deep on them. A lot of really cool stuff there. Azure Container Apps is a serverless platform that allows a setup and run like Kubernetes as a compute infrastructure without the upfront lift of Kubernetes. You can think of it as kind of like a Kubernetes, but just add water. So it's a thing that we talked about and released back in 2022 in general availability as part of Microsoft's Build Cloud Native push. And so now it is one of the major compute resources that we use. This is going to help us run both our API and our React app, both of which are running inside Docker containers. The Python API runs in a Docker container, but also so does the React app. There's a key there. Sometimes we think about those two platforms as being different. They are different in the language, but they are not different in the deployment because the deployment is abstracted. The output of the engineering team that builds the React app and the output of the engineering team that builds the Python API is a Docker image. And those Docker images go into a container registry. And so the next thing is the Azure Container Registry. Azure Container Registry allows you to build and store and manage those container images so that you can deploy them and iterate on them and roll back. When we talk about the storage, we're talking about Azure Cosmos database, and we're talking specifically in this case about the NoSQL implementation. There are multiple implementations, such as relational and vector databases, but it's really meant for any type of modern web app development. And so what we're gonna do is we're gonna be storing the scores in there and storing some information, just a basic implementation of the persistence. The last thing that we have here is Azure Storage. Whoop. There we go. All right. And if there wasn't a bug in the demo, then there wouldn't be a good demo. So that's one demo gremlin down, got 2 more to go. All right, so Azure Cosmos DB is fully managed, and it is meant for storing different types of workloads in the persistence layer. In this case, we're gonna be storing the score data. It is different than the storage account, which is where the files, the binaries of the implementation go. Now, both of those are you could consider them cloud-based storage. They have different properties, and there are other resources out in Azure that are like this that could be used for specific workloads. In this case, we're just gonna demo these 2 today. The last part we're gonna talk about before we actually dive into the demo is how GitHub Copilot shortens the time it takes to write game code. All the code that you're about to see and all the code that's in all of the examples was written by GitHub Copilot. This is not a marketing pitch. I'm writing most and the best code that I've ever written in my career thanks to Copilot. Copilot takes the toil out of the work of writing code. You express your solution in natural language, and you use your engineering expertise and your mindset to guide Copilot for better accuracy. Instead of writing code from scratch, we get 80% of the way there, and then we iterate our way to completion. Refactoring code is directed by us, the engineers, and handled by Copilot. And using Copilot also helps you write in different languages, especially languages that you're learning. So there are some caveats. Copilot is not magic. It's software. Copilot can and will be wrong, just like us. Copilot has limitations. And just like us, Copilot works better when you provide it smaller, more contextually rich tasks instead of large, ambiguous, or ambitious projects. The difference between saying, hey, I need this one method, or I need to refactor this piece of code, versus I need to write a game. Those are 2 very different altitudes, 2 very different depths. So this example here is how we were writing a Unity UXML file and refactoring it to use a new USS. So inside of Unity, there is a development implementation of the user interface. It uses a very similar web-based implementation using UXML, Unity XML, and USS, kind of like CSS. And so I asked Copilot to write me the UXML, and it put all of that stuff, and you can see the styles are inline. Now, being a web person, I know that I don't want inline styles, I want a style sheet. So we had it, said, can you refactor this code so that all of the files in used classes apply to this style? And you can say, sure, and print it out, and we actually ended up using that implementation. Here's another one. In the Flask API that we built, a Python API, it has endpoints. There was an endpoint for saving the tab score and getting the tab score on the left-hand side. Me being tired and not wanting to write it all from scratch, I said, you know what? I'm gonna literally select all the code, and I'm gonna say, hey, I need the same handler but for spaces. Can we use this and replace the types and naming conventions? That's like an offhand comment. I'd see you in the hallway like, hey, can we replace the spaces controller for the tabs controller? That's something that you would say to a colleague or a friend. Copilot did it 100% on that one. Now, I said 80%, but sometimes it does pretty good. So let's build a game and deploy it in real time. And disclaimer, there will be bugs. We've already had one. So what are we going to do in the high level? First, we're going to spin up some GitHub Codespaces for the RESTful and API and the React app. Second, we're going to make feature changes live and deploy the updates to production. And last, we're actually going to play the game and settle the debate for once and all, tabs versus spaces. And so everybody's going to be able to actually play the game. I'm going to share out the chat. So you can play it online too if you're watching. You're not here in Seattle, you're still online. You could also play it as well. This is deployed in the cloud and it is cloud native. That's the benefit of it. What are we going to do? The details. We're going to see how far we get on this. First, we're going to open up Unity 3D and take a look at the RESTful implementation for our WebGL game tabs versus spaces. This WebGL implementation is a very basic kind of boilerplate where it reaches out and it grabs information from the RESTful API that we had. We're going to use GitHub Codespaces to spin up a short-lived dev environment for the existing Python app. We're going to add a new endpoint to get both scores and respond with a JSON response. We're going to commit and push that Python API via GitHub Actions, Docker, and Azure Container Registry. We're going to spin up a new GitHub Codespace for an existing React app. We're going to integrate that endpoint into the React app. We're going to commit and push that to production using the same GitHub Actions, Docker, and Container Registry. And then we're going to encourage everybody to join the game and see who wins. So now we're going to switch over. We're going to log in. Okay. Great. Okay, so here what we can see is this is the Unity editor. Not going to go super into detail about it. This could be done with any game platform. Godot, Unreal, Xbox, anything. We are using Unity in this case because it's something I'm familiar with and it's free. All of the tools that you're seeing here are also free and available, open source. Everything is on GitHub and you can download it and play it and ask me or anybody else how to implement it into your solution. So what we're going to see over here on the right-hand side is the game editor view pane, and the scene is what the developer, or as we see it. So this is, on the right-hand side, is what the user is going to see, and on the other side is what we're going to see as developers. And so there's a little bit of magic that's going on in here. I'm just going to play it really quick to show people what to expect. So this game is very basic. It's a button masher, and what it does is it generates two things. One is a tab, and one is a space prefab. Those objects are three-dimensional and they have a little bit of physics. And so when we click the space button, we see a red cube comes out, a 1x1 cube. We click tab, we see a 4x1. And so also we can see that these numbers here are increasing. Tabs. So tabs is 327, space is 432. So that means that at roughly 700 button clicks we've had so far, and all of that information is being stored in Azure Cosmos. And every time I click that button, we're actually storing a thing in Cosmos and then returning that within like a second. And that's with no further optimization, literally just out of the box. And so what we're going to do now is we're going to take a look at the code and how it works. And we're not going to go into it super deep, but here's what we're going to do. We are going to take a look at this button manager, and we are going to look at the alignment here of clicking and making a request. And so let me actually zoom in here a little bit, make this a little bit bigger so people can see it. So when we click the button on line 42, we are going to call an on-button clicked tab prefab. That generates the three-dimensional object. That three-dimensional object is the visualization of the game experience. The mechanical piece is underneath it, which is the tab service. Tab service calls a method called attempt to add tab score, and it passes a callback called fetch tab score. So if we take a look at tab service is a Unity mono behavior that extends simple web service. Simple web service is an implementation that I've used in other games, and it builds on top of Unity's web request platform and is the way that you interact with objects in the cloud over HTTP and HTTPS. There are other lower level transport systems, but for right now, we're just going to be using the Unity web request. And so it has two methods, one called get tab score and one called attempt to add tab score. And you can see that they call two methods, base get and base post. And those are utility methods that make HTTP get and HTTP post requests. And we can see that when we make those requests, they interact and actually affect the game world. And so what's really cool is that let's click here, click spaces, And so we have 437. And so just in the API, this is there we go. And so you can see up in the upper left-hand corner, 437. And so if I switch back here, I'm still in the editor, I haven't deployed any of the game, I click spaces again, and I refresh, 441. So that is why it's so valuable to use persistence that's not connected to the game. I can actually change the functionality while not rebuilding the game components. And so what we're going to do now is we're going to switch over to the API, and let's see. And so what we're going to do is we're going to open up our code space. And so you're actually going to see this start load up here. It says setting up the remote connection, starting code space. And then in the lower left-hand corner, what you're going to see is a little green spinning thing that says opening up remote. The name that will pop up there, I think it's called 𝗦𝗲𝗀𝗀𝗀𝗀, is generated programmatically, and it represents the code space that I created in GitHub. So when I go to GitHub Codespaces, I can actually go ahead and create multiple ones of them, and I can have it run on any branch I want. And so as a developer, rather than pulling the branch down onto my machine and building it on my machine and making sure that my machine is all configured, I run it in Codespaces because I know that everything is configured perfectly. And the way that these things connect is by using Docker. Docker allows us to run it remotely, run it locally, all doing the same stuff. And so what we're going to do is we're going to take a look at the application here, and we're going to click on this. And so this is a very basic Python application. You can see that we import Flask, which is a RESTful library similar to Quart. And what it does is it allows us to expose RESTful endpoints. And you can see that there are 4 endpoints. And so what I'm actually going to do is, before I tell you guys this, I'm just going to do this. I'm going to say, hey, explain. Oh. Please explain this. And so there's a couple different ways. You saw the hotkey, I accidentally clicked on the terminal, but what's going to happen is it's going to start explaining the application. So as a developer, you don't actually have to read it all to figure it out right away. And so now that it has a little bit of context, you have it read it to you, then you say, okay, here's what I want it to do. And so what we're going to do is we're going to say, I need to create a new handler that returns all scores, both tabs and spaces, like this. And then we're going to do this. And I'm not even going to write the right JSON. One of the things is, don't need to be, you can even misspell things. As a person who has dyslexia, I struggle with misspelling things all the time. I let Copilot take the wheel, and I guide it where to go. And so now, as we're talking, as I'm doing something else, I can get the code that I need. And so this code here shows me exactly what I need to do. So why don't we go ahead, and we're going to do that. We're going to click this insert button, and we're going to click save. We've added a new handler to the system. It knew the code. It knew that tabs get tab score and spaces get space score existed. It knew all of that stuff before I told it. That right there is what changes us as engineers and developers. We don't have to know every single line. We can let GitHub Copilot help us, and while we're doing one thing, it can do another. And so what we're going to do now is we're going to build the Docker image. So typically, you would run that on the command line saying something like docker compose, or in this case, since we're using VS Code, I'm going to use a little trick, which is the default build command, Control-Shift-B if you're on PC, or Command-Shift-B if you're on Macintosh or Linux. And you can see now that the terminal is running the implementation of the Docker image. And our application is running on port 5000. So 5001, excuse me. And so what we're going to do is we're going to go back here, and we're going to type in localhost 5001, and the URL was scores. Oh, scores with an S. All right. Now we have an error. Perfect. Why do we have an error? Because we took the things from Copilot 100%. That is a misnomer. We don't want to take everything at face value. Just like other developers, Copilot can make mistakes. And that's okay, because sometimes the mistakes are on our behalf. As we ask, we say, hey, do it this way, and that actually might not be the way. So let's take a look at this. It says, oh, response JSON is not serialized. Okay, so that's not really all that great. I wonder why. So let's take a look at this, and we're going to open up Copilot again. We're going to say, literally going to come up here, copy this, type error, paste that in there. And now what it's going to do is it's going to say that the error is because the response object isn't accurately typed. And that's because the way that it's being typed is incorrect, because it's returning an object. And so what we want to do is we want to use the Flask response object. So I'm going to say, please use the Flask response object with a 200 response. So now it's telling us to import JSONify and then solve the problem. There, we know we can solve the problem. So what we're going to do now is we're going to grab this, bring this up here, just do a little best cases. And so we're going to save the file, and as you can see, it's automatically done a hot reload, refresh, and the API is up to date. And so we are still getting an error. These errors come from us trying to do something and not being really clear on it. That is where, as developers, we want to drive the acceleration, but also be mindful that we need to be concise. And so what we're going to do is we're going to take a look at one of the implementations here. And we're going to see that this response here, like this, right? And so how about this? We'll go like this, and we'll copy app, and we'll take this return. Like that. Then what we're going to do response. Okay. So now if we refresh, we can see that it's not broken, but nothing's coming out. So gremlin number 2. We've completed. We've had a problem, we ran into it, we resolved it in real time. That is engineering at its best. We use GitHub Copilot, we use Cloud Native, and we solve the problem. And so now I'm going to do this last little piece here, and we're just going to say, I can't seem to get this to work. I want it to be JSON and use the Flask response. All right. And there we go. It is telling us 2 different answers before, one using JSONify, one using response. When we were clarifying it, we said, I want it to use this and this. That right there is the conciseness as engineers that we have to give Copilot. It's like, go to Seattle or go to 200 First Street West, 2 very different types of directions. One, you'll get there most of the way. The other one, you're going to get there directly. And so what we're going to do is we're just going to take this and insert this. It's a little copy pasta. Never heard anybody, right? All right, so as a result of that, let's see. It says, in this code, JSONify uses to convert the string, blah, 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 blah. Okay, well, since we're getting so close to the, looks like we're actually we're getting pretty close to the demo. So what we're going to do is we're going to change out and we're going to go over to the React app. And instead of us just getting the scores, what we're going to do is we're going to sum it up and we're going to do a sum score. So what I'm going to do is I'm going to say, instead, I want this to return a sum score using the response object. Great. And I don't want it to be JSON-fied. Okay, great. So what we're going to do is we're going to take this response, total score, paste total score in there. All right. That is why. Okay, and if we can't get it this time, then we're just going to abandon. Okay, well, it looks like we're going to have to abandon. That's gremlin number 3. All right, so I apologize for that. That's part of doing it live, and that's normal. It's okay. I can tell you confidently that it's something that we are iterating on, and not every time does it work. It's not going to be perfect, and that's why I like to show it. It does help us. Sometimes it takes a little bit of time, but I know that if we sat down and debugged it as a team, we could probably figure it out. Being a person who's not very strong at Python, this is some gap where I'm using it to learn myself. And as I go through it, I realize probably could do a little bit learning. So what I'm going to do is I'm going to take this back. I'm going to use some of the Microsoft Learn technology and go ahead and remediate some of the things I didn't get here today. I bet it's probably like something really simple. So what we're going to do is we're going to switch over and we're going to open up our React app. And what we're going to do here is we're going to take this React app and we're going to start up another code space. So you can see the code space here is also setting up a separate implementation. We can take a look. This is the React app here. It's in GitHub. And you can also get to it. It's open source and you can access it here. And this web app is running in a code space, and we can actually click here while we're opening it up. You can see Psychic Space Cod, kind of a cool name. And you can see that it's active and it's on the branch main. As a result of that, when we load up this code space or any other code space, we can switch branches, we can duplicate, we can pin, we can save them, we can make them live longer or shorter. There's a bunch of rules that you can set up. The benefit of this is that now, as a developer, we can just get started. So in this case, what I'm going to do is the same exact technique that we saw with the Python application. I'm going to press Control-Shift-B, Docker Compose. It's a React app. It's building React, not Python, using the same exact paradigm, the same exact implementation. And as a result of that implementation, we can do less work as a team because we know that in the Python application and in the React application, we're going to be doing the same thing. So different teams know how to operate without having to converse. That type of stuff might not be that big of a deal if you're just on one person team. But if you're on a team of 2 people, or a team of 10, or a team of 100, those little things add up. And it can add up to thousands or hundreds or millions of dollars. And so now we can see that this application is running. It's running locally. And so I'm just going to go ahead and I'm actually going to open up this localhost here. And we can see the game is live. Now, what I'm going to do, and this is another beautiful thing about Copilot, about Codespaces, is that the ports here, these ports are forwarding. This one's saying that on port 5173, we're going to forward the local host 127.001:5173, and so we can do local host. But let's say that you wanted to share that with somebody, perhaps somebody in the chat, or somebody that you were working with, maybe a designer or another developer. What we can do is we can right-click this, click Change Port Visibility to Public. And all of a sudden, you see that the forwarded address has a different value. And so what we're going to do is we're actually going to open this up in the browser. We're going to see this. This is super important. Security is a number one. In Microsoft, we say it's a P0. Making sure that you're able to be secure is part of cloud native, and it is a cornerstone. As a result, what we're going to do here is we're going to read this and make sure that everything's okay. It says, you're about to access a development port on somebody's code space. Only continue this website if you trust whoever sent a link. I hope that you guys will trust me. This is something that we do every time, and we make sure that we're reading links, we're looking at things, and we're ensuring that it's not nefarious before we activate it. So what we're going to do is we're actually going to click the continue button, and what's going to happen is you're going to see that this application here is the same application that's running locally. So how does that work? It works because the cloud space, or the code space itself, is running remotely. It runs in a remote environment, but it is accessible locally as if it were running on your computer. The benefit is that when I change the port forwarding from private to public, I get a fully qualified domain name. Psychic cod dot and then a bunch of salt dot app.github.dev. This is a whole application, SSL, fully qualified domain name, routing, firewall, all of the stuff that you need to get going right here. Now, here's another cool part. If you take a look at that link, if anybody has access to that link, and you can get that either in the chat or right here if you take a picture of it, what we're going to do is we're actually going to come back here and we're going to go over to this screen and we're going to change this version, and I'm going to do a little dual screen here, get a little crazy. Okay, so for the people who are out there on the World Wide Web, 0.05. Oh, I see somebody in the crowd's already doing it. All right, cool. What we're going to do is we're going to change this to 6. Click Save, refresh, reloaded, online, real time. How cool is that? Now, there's a lot of cool things that are going on there. There's hot module reloading, there's Docker, there's a bunch of stuff that's in there. But the real value is I'm changing something real time. I need to do a presentation. It's broken, it's whatever. That's a way to get there. And so the whole point about cloud native is let's deploy rapidly, quickly, and fast so that the business can get the value. And so I know we're coming to time, and so what we're going to do here is I'm going to share out the example here. We're going to click the play button, and what's going to happen is I'm actually going to go back to 5 because version 6 doesn't exist yet. And what we're going to do is we're going to click the play button. I'm going to full screen this here. And so now you can see that it's loading the game in, and what it actually did was it loaded the WebGL application into the user interface, full screened. I used CSS to full screen the application, and I used React components to display the WebGL piece. You can communicate back and forth through the connectors. Now, the same game that we saw the last time, there it is. And so when we click the Spaces button, we can see, oh, and so as people are playing, see, I'm clicking once, 632, 635. All right, looks like Tabs isn't going to win. And so this game right here is a very basic implementation of the cloud native game space, and it is a very basic implementation of a game itself. But the point is that cloud native applications and building with AI accelerates everybody, not just big teams, not just huge game studios, but game developers like you and me. And so I'm really excited to come and talk about this today. If there is something that you would like to see and you would like to talk about in the future, I'm very happy to do that. And here are all of the links that we talked about today, all of the resources that you saw. And again, my name is Max, and if you want any help, feel free to reach out to me, and we'd be more than happy to help. So I want to say thank you so much for coming to Build, and I hope to see you soon.